So today we're going to learn about complex and imaginary numbers. Imaginary numbers are denoted by the symbol I, where I is equal to square root of -1. So first we're going to talk about the 4 common patterns of I. So we have I squared, I cubed, and I to the 4th. So first let's simplify I squared. So we know that I is equal to square root of -1. So we have square root of -1 squared, which is equal to -1. Next we have I cubed, which is equal to square root of -1 squared times I, which is the same thing as -1 times I, which is equal to -I. So the last pattern we have is I to the 4th power. So we have square root of -1 cubed times I. We know that is the same thing as -I times I, which is equal to -I squared, which is equal to 1. Alright, so the next concept we're going to learn is complex numbers, which are denoted by A plus BI, where A and B are the real numbers. So the A part represents the real part. And then we have BI, which represents the imaginary part. Alright, cool. So for example 1, we have 3 plus 2i. So 3 is a real number, and then 2i is imaginary.
First, we must know all the I exponent patterns. So I equals root -1, I squared equals -1, I cubed equals -I, and I to the 4th is 1. And this pattern repeats. So to find I to the 109th power, we can find the remainder by dividing 109 by 4. And if we do that, we will get 27.25, which just has a remainder of 1. And remainder represents what the exponent is going to be on the I, so this is just going to be I to the 1th power. So just square root of -1. So I to the 109th power is equal to root -1.
So for this example, we're going to have 3 plus 2i in parentheses plus 5 plus 6i in parentheses. So the first thing we're going to do is we're going to remove the parentheses. And now we're going to combine like terms. So we're going to combine the real numbers, which are 3 and 5, and we're going to combine the imaginary numbers, which are 2i and 6i, which should leave you with 8 plus 8i.
In example 4, we have 3 minus 8i in parentheses minus 10i minus 9 in parentheses. So first we want to distribute the negative sign. So we'll have 3 minus 8i minus 10i plus 9. And now we just want to add like terms. So 12 minus 18i.
For example 5, we have 3 plus 2i times 3 minus 2i. For this specific question, we can use a plus b times a minus b, which equals a squared minus b squared. In this question, the a is 3 and the b is 2i. So when we square it, we can get 9 minus 4i squared. We see that I squared equals -1, so we can replace I squared in this equation with -1. Now we have 9 minus 4 times -1, which is just 9 plus 4, and that would equal 13.
So for example 6, we have finding the magnitude of 4 plus 5i. So the formula for finding the magnitude of complex numbers can also be written as the absolute value of a plus bi, which is the same thing as square root a squared plus b squared. So in this case, we can rewrite it. So we have the absolute value 4 plus 5i, which is the same thing as square root of 4 squared plus 5 squared. We can simplify this down, so we have square root of 16 plus 25, which is equal to the square root of 41, which is our final answer.
Example 7, we have two complex numbers, one in the numerator and one in the denominator. So first of all, we don't like complex numbers when they're in the denominator. So in order to get rid of it, we want to multiply by the conjugate of the denominator on both the top and the bottom. The conjugate of the denominator would be 10 minus 5i. We do this because we look at the complex part and we reverse the sign. So let's first simplify the bottom when we multiply by these fractions. We can FOIL out 10 plus 5i and 10 minus 5i. Yes, we FOIL it out. We get 100 minus 50i plus 50i minus 25i squared. We see that the negative 50i and the positive 50i cancel out with each other. So this expression simplifies to 100 plus 25, or 125, which is our denominator. For the numerator, we repeat the same process except with 3 plus 5i and 10 minus 5i. We repeat the FOIL process, we get 30 minus 25i squared plus 50i minus 15i. We can continue to simplify this down and we get 30 plus 25 plus 35i, which is equal to 55 plus 35i. And we can write it back into the numerator of our answer. We see that there is some sort of a common factor. So as a last step, we want to simplify it down. The common factor in this case would be 5. So 125 divided by 5 is just 25. And 55 plus 35i divided by 5 is 11 plus 7i. So our final answer would then end up to be 11 plus 7i over 25.